Today we're doing lesson 5.3, direct variation. First we have to define direct variation, so I want you to put the video on pause and get out your textbook and look up the definition for direct variation. You'll see that it is a rate of change in which the rate remains constant. So for an example, we're going to talk about Mary, who earns $10 per hour babysitting. And what we need to do is to compare the relationship between the money that Mary earns and the hours that she works. So for next class, what I want you to do also is to remind me to tell you a story about Mary and her babysitting that you'll find quite interesting. Can't wait to tell you. So what we need to do to find the relationship is to graph it. So I've got here a table of values representing the relationship between time in hours and the money earned in dollars. Notice time is on the x-axis, money earned is on the y-axis. That way it's easy to graph x and y. So for example, if Mary works 0 hours babysitting, how much money should she expect to earn? Well, that's pretty easy. If you don't work, you don't earn, and she gets $0. If she works for 1 hour babysitting, she should get $10 because she makes $10 per hour. If she babysits for 2 hours, 2 times 10 is $20. 3 hours is 3 times 10, $30. And 4 hours is 4 times 10 for $40. So now we're going to graph it on our coordinate plane. So 0, 0 is right at the origin at that point there. 1 hour, $10, so over 1 up 10. 2 hours, $20, over 2 up to 20. 3 hours, $30 is there. And 4 hours, $40 is here. Now when we draw the line, we have to be careful because Mary cannot work a negative amount of time or earn a negative amount of money. We can't go in to the negative zone. So your line will just start at 0, 0 and continue straight out that way. Notice it is a straight line going only into the positive direction. So I got ahead of myself here. Okay, so the amount of money that Mary earns varies directly as the number of hours that she works. Thus, this is where the definition of direct variation comes from. So what we're going to do right now is we're going to write an equation comparing money earned and the hours that she babysits. So in other words, money that she earns is equal to, well, what is that based on? It's based on how much money she earns per hour and how many hours she actually babysits. So because she makes $10 an hour babysitting, we take the 10 and then we multiply it by the number of hours. So in other words, money is equal to 10 times the number of hours, or M equals 10H. Now the general equation for direct variation is y equals kx, where k is the constant. In terms of Mary babysitting, well, what doesn't change? It's the $10 per hour. It doesn't matter how many hours she babysits, she's still only going to get $10 per hour. So here is one type of question that you're going to see on your homework. If y varies directly as x, and you always have to be told how it varies, because there is going to be 2 different kinds. We're only going to learn direct variation today, but there is another one coming. So if y varies directly as x, and y is 24 when x is 3, find y when x is 4. Now this is a proportion, but we don't get to set it up as a proportion. We have to set it up as a direct variation. So we always start with our general equation. As soon as you see y varies directly as x, so in that order, because y is mentioned first, we write y is equal to kx. So that's the general equation. You do get 1 point for writing that down. You are expected to write it. Now I substitute the value y equals 24 and x equals 3 into the equation because we have to find out what k is. At this point, we don't know. So 24 is equal to k times 3. Now we're solving for k, and we have to ask ourselves, what is the opposite of multiplying k by 3? Well, we're going to divide it. So we divide this side by 3, and we divide this side by 3. Those 3's cancel out, and k is 24 divided by 3 is 8. That's going to be the second point towards your total of 4 for this particular type of question. The third thing you're going to do now is to write the actual equation. Y equals kx is your general. You have to write your actual. That means you have to take the value of k and substitute it back in. So y is equal to, because k is 8, we make it 8x. Now that we have our actual equation, y equals 8x, we can now solve the question. It says find y when x is 4. Right here, x is 4. So all we do is substitute it in. Y equals 8 times 4. And we multiply it out. 8 times 4 is 32. And you are done. So next example. If y varies directly as x, y is 32, x is 8. Find x when y is 24. So we start the same way. Y equals kx. So that's your general. Then we substitute y is 32, x is 8, and we find the value of k. So 32 is equal to k times 8. The opposite of multiplying k by 8 is to divide by 8, both sides. Those 8's cancel, and k is equal to 4. We now have to write the actual equation. So y is equal to 4x. So now it's saying to find x when y is 24. So we substitute y being 24 equals 4x. We're solving for x, so we have to do the opposite of multiplying by 4. So we're going to divide both sides by 4. Those 4's cancel out, and we have x is equal to 6. And we are done that question. Now comes the fun part, solving word problems. Now, the solving of these types of word problems are done the same way. We're going to be using y equals kx as the base graph or the general graph. So my suggestion is when you're doing word problems, I would not use x and y. I would use a letter which will stand for what you're actually finding. Now here it says the height of an object varies directly as the length of the shadow. What are the two important words that are being compared? Well, one of them is the height of the object and the length of the shadow. So I'm going to do the height and the shadow. So first what we have to do is write the general equation. So height, and it can be capital if you want, it doesn't matter, is equal to k times the shadow. So make sure you make a nice little S so it doesn't look like a 5. Now we have to find k. So I tell you that the flagpole is 6 high and the shadow is 10 long. So I'd substitute the 6 and the shadow being 10 and find k. So we have 6 is equal to k times 10. So we divide both sides by 10. They cancel out, and k is equal to. Now you have to be careful with a question like this in terms of what k can be. If you want, you can always use the reduced form as a fraction, which would be 3/5. That will never be an issue. If you do decide to make it into a decimal, that's fine. However, the decimal has to be such that it terminates. If it is a repeating decimal, you do not get to use it, and you have to use the fraction. Now, because 3 over 5 is the same thing as 0.6, if you wanted, you can do k equals 0.6. Both of these are perfectly fine. It does not matter to me which one you use. So I'm actually just going to use the decimal of it. So h is equal to 0.6 s. That's your actual equation. Now it says find the height of the building if the shadow is 45 long. So we have h is equal to 0.6 times the shadow, which is 45. So h is equal to, so get out your calculators and let's multiply that out. I have to get my calculator here as well. So we've got 0.6, we times it by 45, and we get 27. So h is equal to 27. Now at this point, you're not quite done yet. You have a choice. You can either write a full complete sentence with the 27 and its unit, or you can just say h is equal to 27, add the unit, box it, and you're done. That's the way I'm going to do it. So because height is in the form of meters, all I do is add an m for the meters and box it, and I am officially done that question. And we have one more word problem to do. And this is my favorite. It says the amount of chocolate that Mr. Cook can eat varies directly with the time that he eats. So again, don't use y and x for the word problems. Let's pick a letter that stands for the words that are being compared. So it's the amount of chocolate that Mr. Cook eats. So I'm going to use C for chocolate. Varies directly with the time that he eats. So, since we're talking about time, I'm just going to use T. So we've got C is equal to K times T. And again, they can be capital letters or lowercase, it doesn't matter. You can also use any letter you want as long as you yourself remember which one is which. If you want to use X and Y, you're welcome to, but it does get confusing as to when you're plugging numbers in which one is which. I'm now ready to find K. So it says I can eat 6 pounds of chocolate in a time of 3 minutes. So chocolate is 6 equals K times minutes of 3. I'm now solving for K. The opposite of multiplying by 3 is divide. So I divide both sides by 3, cross those out, and K is equal to 2. I boxed that. Now I have to write my actual equation. So I replaced the K with the 2 that I just found. So C is equal to 2T. Now I have to find how many pounds I can eat in 12 minutes. Because minutes is time, that's where the 12 is going to go. So C is equal to 2 times 12. So C is equal to 24. Again, you have a choice. You can write a completion sentence including the unit, or you can just add the unit, box it, and be done. I'm just going to add my unit. Let's see. So because it's asking for pounds, or sorry, for how many pounds of chocolate, that is my unit. Now, I always get asked, can I use the abbreviation? Yes, you can. If you want to write LBS, that's perfectly fine, as long as the abbreviation that you're using is the correct accepted form, then be my guest, you can use it. If you always just want to write out the word, it's always safe to do that. So I'm going to box my 24 pounds, and I'm actually done with that question. Now tomorrow, or next class, I want you to remind me to tell you a story about this as well, because I do have a funny story about me and chocolate that you'll find interesting. So now it's time for our assignment. We're going to be doing page 241, numbers 19 through 26, and a worksheet, numbers 1 through 10. Thank you for being in my class today.